Floating compressions. I use a little longer connector here. I put it on and I load it first, so now that connector is anchored in position. I take my 2 fingers and spread out. I run it up along the straw. If you run it like this, the sticks don't resist buckling very well, so they want to buckle. So I run right up along the stick. Grab the hook and load it. Now I have an elastic outside the stick. So I'll do that with 3 sticks. Notice how I'm pulling down along the stick, not out so it buckles, but to avoid buckling, I'm pulling along the stick. The sticks resist compression, but not buckling. Now these sticks are modified so I can use them for floating compressions. And the way I do it, it might appear a little redundant, and after you practice a few times, you'll certainly streamline this process. You don't have to prepare the sticks ahead of time, but I do. I remove the rubber band, and I expose the clip. The elastic pointing up, that's going to be the outside of the structure. The clip pointing up towards the outside of the structure. Slide it under the elastic, clip it on. Then take this elastic, slide up, pinch, and load the clip. Repeat. The last connection of the joint's a little harder to make because you're working with a short piece of elastic here. If you need more room, you can just slide this down so you have room. But again, split the elastic with your fingers around the stick, slide up the stick to expose the clip, clip onto the other stick, slide back up, and load the clip. Try and make that a nice equilateral triangle. And notice what happens when all ends are pushed down. The sticks separate, so they're not touching each other. That's why it's called a floating compression. The compression members are floating in a tensile network. They don't touch each other. That allows for the construction of very springy structures supported essentially by surface tension. So I get the tower that resists earthquakes. Even though the cube itself is not rigid, made by other methods, made by floating compressions, the cubes here are rigid because the elastics are forming a surface tension holding everything together, pushing everything towards the center and forcing it to hold its form. One of the nice things about making floating compressions like this is you can change the position of where the stick is attached to the elastic. So you can reform your structures and explore other types of structures. I could do this all day. A little tighter structure, but still a tower that resists earthquakes. The beauty of KlypStyx is how it allows you to explore creativity. I never built that structure before. I just found it this time, for the first time. I don't know that anyone's ever seen this structure before. Cube octahedron, cube octahedron. It's a pair of cube octahedrons on top of each other. If you watch the black elastics, they're forming a square, triangles, squares, triangles. So an original just for you.